Hey everybody, this is Mrs. Snook with section 6.6, which is about solving linear inequalities, systems of linear inequalities. So earlier in the chapter, we solved systems of equations, and then last time in section 6.5, we graphed linear inequalities. And today we're going to pull all of that together. We're going to have a system of two linear inequalities, and we're going to solve that system by graphing. So here's the step-by-step process we're going to do. First thing you want to do is you want to write the inequalities in slope-intercept form. Which looks like y equals mx plus b. And then we're going to graph the first inequality. And just like last time, we're going to follow the rules about whether it's a dotted line or a solid line. And then we're going to shade above or below and use a test point to make sure that you're shading in the right area. My favorite test point is 0, 0. That's the origin. And then graph your second inequality. Again, solid or dashed. And then shade using your test point of 0, 0. And the solution is going to be the intersection of the two shaded areas. In other words, the part of the graph that was shaded twice. Let's go ahead and solve one of these by hand so that you see what I mean. So our first inequality is y is less than 2x minus 3. That's already in slope-intercept form, so I'm going to leave it alone. The second inequality is 2x plus y is greater than 2. That's in standard form, so I'm going to convert it to slope-intercept. Subtract the 2x from both sides, and I get y is greater than negative 2x plus 2. And that's going to be my second inequality. So let's start graphing. First one, the y-intercept is negative 3, so I'm going to put a point there. My slope is 2, so I'm going to go up 2 and to the right 1, which will give me my second point. And this one is a less than, and there's no equal under there, so this is going to be a dashed line. And what I'm going to do to make it easier for myself is I'm going to plot some more points. So up 2 over 1. So here comes my dashed line. Okay. And I'm going to use a yellow highlighter to shade. Test point. Put in a 0 for x and a 0 for y, and I get 0 is less than negative 3. Now that's not true. 0 is not less than negative 3. So when I shade, I'm not going to shade on the side where the origin is. Instead, I'm going to shade the other side. So here comes my shading. This is my shaded side. Now I'm going to do my second inequality. I have a y-intercept at plus 2 right there. My slope is negative 2, so I'm going to go down 2 and to the right 1. And I am going to just plot myself some extra points just to make it a bit easier for me. Okay. And this one is also dashed. So I'm going to draw this in like this. Here's my dashed line coming in. Test point for this one. So 0 greater than 2. That is also not true. So I'm not going to shade on the side of this line where the origin is. I'm going to shade on the other side. And I am going to use blue. And what's going to happen is when I shade this other side, the area that's the intersection is going to turn green. So right there, that green area, that's where our solution is. Now, oftentimes we'll ask you, give me one point that's a solution. So I'm going to go to any point I want to in the green area. Just make sure I don't pick one that's on one of the lines. So I'm going to pick this one right here. That's the point 6, 2. And that point is an example of a solution. I might also ask you for something that's not a solution. I can pick any point that's not in the green area. So how about this one? That's our point -3, +2. Not a solution. So that's how you do these by hand. Let's do one on Delta Math. So here I have this set up from Delta Math. I have two inequalities. Here's my first inequality. Here's my second inequality. And they're both already in slope-intercept form. So now all I have to do is graph my lines. So looking at this first one, I do have this little equal under here, so this is going to be solid. And if I put in my test point 0, 0, I get 0 greater than or equal to -3, which is true. So I'm going to shade on the side where the origin is. So let's go over to Delta Math. So here's that same problem in Delta Math. Graphing the first inequality, my y-intercept, I'm going to take that away, is at -3. And then my slope is -3/2, so I'm going to go down 3 and over 2. I have an equal bar here, so I want this to be a solid line. And I need to shade. I said I wanted to shade where the origin was, so this is how this shading is going to play out. Now let's go back and do our second inequality. Second one, also solid. And plug in my 0, 0. I get 0 greater than or equal to 5, which is not true. So when I shade the second inequality, I don't want to shade where the origin is. So going back to Delta Math, for my second inequality, y-intercept is at 5. I'm going to go up 2 over 1. That's my second line. I do want it solid. Now let's figure out the shading. Right here, if I shade there, I'm shading where the origin is, and that's not what I want. So over here. Now let's find the area that's the intersection. It's been double shaded. So this one line, see how it's highlighted? That shades it light green. The other one is shading, yeah, whatever, go away. My other one is shading light blue. So this area in here that's that darker green, that's where our solution set is. And it is asking us for a point in the solution set. So I'm going to come over here in the dark green area. I can pick any point I want. So how about x is 2 and y is 8? So I'm going to put 2, 8. Got my green check, so I got it. Now the next kind of problem we're going to do is this kind where we are in context. And looking at Delta Math, it wants me to decide which symbol to use. It wants me to put in the inequality over here. Click plot, it'll plot the line for me. And then do the same thing for second inequality. And then I have to choose where to shade. And then at the bottom, it's asking for one possible solution. So let's go over into OneNote where I can show my work. Now this is a story problem, so make sure you do your 3 reads. Nolan has X dimes and Y nickels. He has no less than 15 coins worth more than, I cut it off, more than $1 combined. Solve this system of inequalities graphically and determine one possible solution. So from your first read, your story is that Nolan has some change and there are nickels and dimes. From the second read, you're going to focus on what it's asking you to do. And I like to go ahead and underline. It says to solve the system of inequalities graphically, so I'm going to graph them and determine one possible solution. So I'm going to fill in a solution. And then the third read is asking me for the information. I have X dimes and Y nickels. And then he has no less than 15 coins and is worth no more than $1 combined. So X equals dimes. I want to use a thinner marker. Y equals nickels. I know that he has no less than 15 coins. So X plus Y, no less than. That means I'm allowed to have 15 coins because that's not less than 15. I'm also allowed to have more coins than 15. So this is going to be a greater than or equal to. And then I want to put this in slope-intercept form for graphing. So I'm going to go ahead and subtract x from both sides. So I get y is greater than or equal to negative x plus 15. That's going to be my first inequality. When I go to Delta Math, I'm going to put it like that. Second inequality, no more than $1 combined. So this is where I'm going to write an inequality about the money. Now I know that a dime is worth 10 cents. So 0.1x plus nickels are worth 5 cents, 0.05y, and then 1. And it has to be worth no more than 1. 1 is fine, and then anything less than 1 is fine. So that's my second equation. And again, let's convert this to slope-intercept. So I'm going to subtract 0.1 x from both sides. I get 0.05y is less than or equal to negative 0.1 x plus 1. And then I need to clear out that 0.05. So I need to divide both sides by 0.05. So y is going to be less than or equal. Take 0.1 and divide it by 0.05. I get 2. Negative 2x plus, now I'm going to do 1 divided by 0.05, and I get 20. So this is going to be my second inequality. This is going to be a less than or equal to negative 2x plus 20. Now before I go into Delta Math, let's go ahead and do our test points and figure out which sides to shade. Using my first inequality, if I plug in a 0, 0, so 0 for x and 0 for y, I would get from here a 0 is greater than or equal to 15, which is not true. So I'm not shading where the origin is on the first one. The second one, plug in 0, 0, and I get 0 less than or equal to 1. And that is true. So the second one, I do want to shade where the origin is. All right, so I'm going to put my paper where I did my work over to the side so I can see it. And I'm going to be here in Delta Math. The first equation that I said was going to be y greater than or equal to negative x plus 15. I'm going to plot this. So it did the work for me. It plotted it for me. And now I'm going to choose the side to shade. Well, that's the side where the origin is. I don't want to shade that, so I'm switching it over here. Now let's do the next one. I have negative 2x plus 20. Going to plot that. And then I said I wanted to shade the side where the origin is. So not there, but there. So that is now what my inequality looks like. And we need to have one possible solution for how many dimes and nickels that Nolan has. So over here where it's a dark green, I have a x is 1 and y is positive 20. So I could have 1 dime and 20 nickels. Let's see if that works in here in this dark category. Can we have 1 dime and 20 nickels? Okay. So picking our point. I can go anywhere in that green. I changed my mind. How about, let's do 3. And if I do 3, 1, 2, 3, that looks like 13 nickels. And there we have it. Got our green arrow on that one, or green check mark. So that's it for today. Thank you for watching. Have yourself a great day.